Hello all, this is Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths. So we are in the chapter of binomial theorem and our today's topic is to find the number of rational terms or the number of irrational terms in a given binomial expansion. Okay, so this model is observed in previous JEE mains model questions. So let us see how to find the number of rational terms and number of irrational terms in a given binomial expansion with some questions. So we have our presence in the other platforms also like Instagram, Facebook, Threads and Twitter. So do search for Math with Sandeep. This is the name of the page. You can search for it and you can find me where I'll be uploading some questions on all these chapters, and at the same time I'll be uploading the notes of the topics that I'm discussing in these videos, right? So do subscribe my channel if you're new to this channel. Fine, let us continue. Let us start with our first question on this particular topic. Here is our first question. So they told us to find the number of rational terms in this particular binomial expansion, right? First, if you want to find the number of rational terms, first let us write the general term. So what is it? The general term is TR plus 1, which is NCR. So index is 100, right? N value is 100. So NCR, 100 CR into the first term is 5 power 1 by 8 whole power 100 minus r into the second term, which is 6th root of 2, that means 2 power 1 by 6 whole power r. So we can write it as 100 cr into 5 power. When I multiply the powers, I'll get 100 minus r by 8 into 2 power. Multiply these two, you'll get r by 6. So this is our general term, dear students. So this is our general term. This represents all the terms in this binomial expansion, right? See, a term will be called as a rational term when the power, this power and this power are integers. Remember, both the powers must be integers. If the powers are not integers, if they are in p by q form, for example, like 5 power 1 by 2, then it becomes an irrational term. Remember this, the power must be an integer, right? So let us see how to make sure that the powers are integers. First of all, 2 power must be an integer. We will start with this. 2 power, what is it? R by 6. R by 6 must be an integer, right? And first thing is, look at this condition for R. R is greater than or equal to 0 and less than or equal to 100. First point is, you should remember this. Next, second point, the power of 2 must be an integer, right? That means r by 6 must be an integer. So what are the values of r for which r by 6 is integer? Obviously r must be a multiple of 6, correct or not? So r must be a multiple of 6. So what are the multiples of 6 from 0 to 100? 0, 6, 12, 18 and so on. The last multiple of 6 before 100 will be 96. Right? Now let us see fine. Okay, next, the third condition is that even the power of 5 also must be a integer, correct or not? Even 100 minus r by 8, 100 minus r by 8 must be an integer, correct or not? So among these values of r, we will pick some. Let us see which values of r make this one as an integer. When r is 0, we will get 100 minus 0, so 100 by 8. 100 by 8 is not an integer. You will get 25 by 2. It is not an integer. So 0 cannot be taken. Next, let us substitute 6. 100 minus 6, 94. 94 by 8 is not an integer. 94 by 8 is not an integer. We will get 47 by 4. So even 6 cannot be taken. Next, let us check with 12. 100 minus 12, 88. 88 by 8, 11. 11 is an integer. So we can take 12. The first value of r which is selected here is 12. Next, check with 18. Substitute r value as 18. 100 minus 18 is 82. 82 by 8 is not an integer. So what is the next value of r? After 18, the next multiple of 6 here is 24, correct or not? So 24, if you substitute, 100 minus 24 will be 76. 76 is not divisible by 8, so even 24 cannot be taken. Next, after 24 we have 30. Substitute 30. 100 minus 30. 100 minus 30 is 70. 70 by 8 is not an integer. and next value of r is 36. So 36, if you substitute r as 36, 100 minus 36 is 64. 64 by 8 is an integer. 64 by 8 is 8. That means 36 is selected. Enough. I'm not saying these two are the values of r. If you know the first two values, automatically they might be, most probably they will be in AP. Correct? So 12 after we got 36. So the common difference here is 24. Correct or not? So we got a common difference of 24. Now add that 24 to 36. What is the next number? 36 plus 24 will be 60. Now check whether 60 is accepted here or not. 100 minus 60, 40. 40 by 8 is 5. Yes, it is an integer. So R value 60 is accepted. Okay, now here 100 minus 60 by 8 is 5. Yes, 60 is accepted. Now add 24 for 60. So 60 plus 24 will be 84. Check whether 84 is accepted here or not. 100 minus 84 is 16. 16 by 8 is 2. Integer. Yes, 84 is also accepted. 84 plus 24 is 108. But R value should be less than or equal to 100. So that's it. Over. I'm not taking the values after this. Because 84 plus 24 is 108. 108 is not the accepted value of r. R value should be less than or equal to 100. That's it. Only these four values of r. Only for these four values of r, the general term will be a rational term. Why means only for these values of r, the power of 5 is an integer, the power of 2 is an integer, which means that this is a integer. Of course, it is integer and at the same time rational term. This also becomes an integer. So overall value will become an integer or rational term. So I hope you understood this. Only for these values of r, the power of 5 is a integer and the power of 2 is a integer, which means that the overall term will be what? Integer into integer into integer. So it is an integral term and at the same time rational term. So therefore, only 4 values are accepted from 0 to 100. For 4 values of r, we will get 4 terms. Who are the 4 terms? When r value is 12, we'll get t 12 plus 1. When r value is 36, we'll get t 36 plus 1. And when r value is 60, we'll get t 60 plus 1. And when r value is 84, we get t 84 plus 1. So which means the 13th term, the 37th term, 61st term and 85th term. Only these 4 terms are rational terms, and particularly in this example they are also integral terms. Okay, now so out of these 101 terms, please observe this binomial expansion contains 101 terms. If the index is n, the number of terms is n plus 1. In this binomial expansion we have 101 terms. Out of that 101 terms, only 4 terms are rational terms and all the remaining are irrational terms. Right? So now the answer for this, they are asking number of rational terms. We got 4 rational terms. The answer is 4. Now let us see with the second question. Okay, here is our second question. In second question, they said the sum of all those terms which are rational numbers in this particular expansion. In the first question, they just asked us to find the number of rational terms. And in this question, they told us to find the sum of the rational terms. So first, let us find the number of rational terms. We will see who are the rational terms. We will find their values and we will add them. Right? Same process. Like how we have solved the first question, even this also will be solved. First, let us write the general term. So what is the general term here? For this particular binomial expansion of 2 power 1 by 3 plus 3 power 1 by 4 whole power 12. So the general term is TR plus 1 NCR. NCR means 12CR into the first term 2 power 1 by 3 whole power 12 minus R whole power 12 minus R into the second term 3 power 1 by 4 whole power R. And when you simplify it, we'll get 12CR into 2 power. Multiply the powers, we'll get 12 minus R by 3 and 3 power. Multiply the powers, you'll get R by 4. So as I told you in the previous example, if you want this term to be rational term, the power of 2 must be a integer and the power of 3 must be a integer. Correct or not? So based on this only we are solving this question. So first condition. First condition, what about R value? From 12CR, it's very much clear that R value is greater than or equal to 0 and less than or equal to 12. That is the condition of NCR, right? So R value is from 0 to 12. It can be any integer from 0 to 12. Remember, R is an integer. Number 2, second condition. The power of 3 must be an integer. That means R by 4 must be an integer. So which means R is what multiple? It should be divisible by 4. So R should be a 4 multiple. And what are the 4 multiples from 0 to 12? 0, 4, 8, 12. So only 4 values of R are divisible by 4. And what is the third condition? The third condition is that the power of 2 also must be an integer. Who is the power of 2 here? So 12 minus R by 3 must be an integer. So first of all, and let me select the first value of R from here. Substitute R as 0. 12 minus 0 is 12. 12 by 3 is 4, integer. So R value 0 is accepted here. So R value 0 is accepted. Next. So R value 0 accepted. Now let us take R value 4 and substitute here in place of R. 12 minus 4 is 8. 8 by 3 is not an integer. So we cannot take the value of 4. Next, check with the value of 8. 12 minus 8 is 4. 4 by 3 is not an integer. So the 8 is also not accepted. Now check with 12. When R value is 12. R value is 12 means 12 minus 12, 0. 0 by 3, 0. It is an integer. 0 is an integer. So we can take 12. So totally only 2 values of R is accepted when R is 0 and R is 12. So therefore, dear students, when R is 0, the general term becomes a rational term, and when R is 12, the general term becomes a rational term. I hope you understand this. Why it is a rational term? Because when R is 0 and when R is 12, the powers become integers, and therefore the entire terms become, these terms becomes what? If the power is integer, this is an integer. If the power is an integer, this is an integer, and this is already an integer. The product of 3 integers is an integer, and the integer is integral term is also a rational term. Correct or not? Yes, for values of R and 0 and 12, this term becomes what? Integral term, which is also rational term. So let us see who are the rational terms. So when R is 0, the term is T0 plus 1, which is nothing but T1. The first term is a rational term. And when R is 12, it is T12 plus 1. That means T13, the 13th term. Only 2 terms are rational terms. So it is the first term and it is the 13th term. And what are we supposed to do here? The sum of all those terms which are rational. So we are supposed to find the value of T1 and we are supposed to find the value of T13 and we will add their values, right? Now let us see what is T1 value and T13 value. So let us substitute, let us find T1, the first term, by taking R as 0. So 12C0 into 2 power 12 minus 0 is 12 by 3 is 4 into 3 power R value is 0, 0 by 4 is 0. So 12C0 is 1, 2 power 4 is 16 and 3 power 0 is 1. So this is what? 16. The first term is 16. Similarly, we have to find the 13th term. 13th term means T12 plus 1. So R value is 12, right? Now substitute here. 12C12 into 2 power 12 minus 12 is 0 by 3 is 0 into 3 power R value is 12. 12 by 4 is 3. So 12C12 value is 1. 2 power 0 is 1. 3 cube is 27 and you will get 27. So therefore what is the sum of the rational terms? Sum of rational terms is equal to 16 plus 27, which is equal to 43. Right? The answer for this question is 43. It is the last option. So this was given in previous year mains paper. So I hope it's easy for you, right? Let us go with 2 more examples to get clear clarity about it. In the third example, let us see how to find the number of irrational terms. Here is our third question. In this question, they told if n is the number of irrational terms in the expansion of this, then n minus 1 is divisible by, please observe the question carefully. They told that n is the number of irrational terms in this expansion. Then n minus 1 is divisible by. Some of us, what we will do, we will find the value of n and we will take the option which is divisible by n. Be careful that they told n minus 1 is divisible by what. Okay, now read the question carefully and answer what they have asked for, right? And this is a previous year question. So it was given in March 2021 paper of JEE Mains. Now, before I explain, you can pause the video and first you can try it yourself. The process is very simple. First you find the number of rational terms. I have explained in first example and second example, right? Find the number of rational terms. From the total number of terms, if you subtract the number of rational terms, automatically you get number of irrational terms. It's very much obvious, right? First you pause the video and first you try it yourself and then check whether you are correct or not. Fine. Now let me solve this question. First I will find the number of rational terms. For this I will first find the general term. So I am writing the general term directly. I hope you understand by now. 60CR because NCR into the first term power 60 minus R. So the first term power 60 minus R by 4 will come. You understand how. If you write it, you will understand. Into the second term power R. Second term power R means you will get this. In case if you have not understood this direct step, please refer the previous two examples, right? I have written step by step. Refer the previous examples, then you will understand how I wrote this. So as usual, the first condition says that R value should be between 0 and 60. And second condition says that the power of 5 must be an integer, which means R by 8 must be an integer. So then what are the values of R? The 8 multiples, which is 0, 8, 16, 24, 30, and then what? 36, 42, 48, 54, and then wait a second, I made a mistake. Yes, I made a mistake here, a small mistake. I should take the multiples of 8, not the multiples of 6. So then 8 4s are 32, 8 5s are 40, 48, 56. That's it. So how many values of R? 1, 2, 3, 4, 5, 6, 7, 8. Okay. It is not over. We have to find the third condition also. What is it? The power of 3 also must be an integer. The power of 3 is 60 minus R by 4. Even this must be an integer. Let us see what values of R makes this an integer. If you take R as 0, substitute 60 minus 0 is divisible by 4. 60 by 4 is 15. So 0 is accepted. Next substitute 8. 60 minus 8 is 52. 52 by 4 is 13. Yes, that is also an integer. This also must be an integer. Yes, 16 is also accepted. 8 is accepted. Check with 16. 60 minus 16 is 44. 44 by 4 is 11. Again an integer. 16 is accepted. Similarly, dear students, all values are accepted here. You can check with all the remaining values. Check with 40. 60 minus 40 is 20. By 4 is an integer. Check with 48. 60 minus 48 is 12. By 4 is an integer. Correct or not? All values are accepted. 0, 8, 16, 24, 32, 40, 48 and 56. All 8 values of R are accepted. So which means that for all these values of R, the general term becomes a rational term, right? Since all values of R are accepted here, how many values of R are there if you count? So then we will get 8 different values of R. Then how many number of rational terms? So therefore, dear students, number of rational terms is equal to how much? 8. For 8 values of R, we have 8 rational terms. But the question is what? They are asking number of irrational terms. How to find the number of irrational terms? From total number of terms, we have to subtract the rational terms. From total terms, you remove rational terms, the remaining are irrational terms, right? So, number of Q dash means irrational. Number of irrational terms is equal to total number of terms minus number of rational terms. Since the index is 60, the total number of terms are 61 minus number of rational terms 8. Number of rational terms 8. If you subtract, we will get 53. n value. So they told that then n is the number of irrational terms, right? So n value is 53. But they did not ask n is divisible by what. That is not what they asked. They told n minus 1 is divisible by what. N minus 1 means 52. Now 52 is divisible by what number in the options? It is divisible by 26. 52 is divisible by 26, but not by 30, not by 8, not by 7. So the only correct option is A. So 52 is divisible by 26. The correct option is A. So n minus 1 is divisible by what number? 26, right? So I hope you understood this. So I'll write some questions on the board. You try it yourself and check whether you got the answers or not. So here are two more questions. If n is the number of irrational terms, q dash means irrational terms in the expansion of this, then n minus 2 is divisible by. Okay, now so you can try it and check whether you have got your answer or not. And similarly, fifth question. In fifth question, what they told is to find the number of integral terms. Until now we were discussing about rational terms. Here they are asking about integral terms. Do you think the solution will be different? No, because when the power is an integer, the general term, if you observe clearly, that also will be an integer. Okay na? So same process only in these models. In these two models, rational terms are actually integers only. So you find the number of rational terms, they automatically become the number of integral terms. The rational terms are automatically integral terms in these two expansions. For example, if 3 is like 3 by 4, okay na, or 5 is like 5 by 3, something, if you have got the base as a rational number, then the rational term will not be integral term, need not be integral term, then the rational term need not be integral term. But in the question, the base is a integer only na? So all the rational terms will automatically be integral terms only. You find the number of rational terms. It is same as number of integral terms. Okay, so that's it about this particular topic, dear students. So I hope you understood how to find the number of rational terms and how to find the number of irrational terms in a given binomial expansion. In case if you have understood this, do share this video to your friends. Let them learn as much as possible in binomial theorem, and let me know what you think about in the comment sections. And let me know what answers whether you got the answers or not in the comment sections. And do follow me in other platforms like Instagram, Facebook, Threads or Twitter. Search for Math with Sandeep. You will find me, and I'm uploading the notes of these concepts. Whatever I'm discussing in this video, I'm writing the notes very much clearly, and I'm explaining the solution step by step, and I'm posting it in Insta or Threads. You can find me in those platforms, and you can get the notes from them, right? Thank you. See you all in the next class, next video.